Hi everyone, so today we're doing 7.4 factorising expressions with 2 or 4 terms. So looking first at factorising expressions with 2 terms, if the terms are in an expanded expression, so no brackets, and they have a common factor, the highest common factor is written at the front, and then the remaining factor is left inside the bracket. So for example, 4x squared minus 36, the common factor is 4, so the 4 comes at the front of the bracket, and what's left over is the x squared, and then 36 divided by 4 is 9. This is a general form here of what we're doing for a difference of 2 squares. So if you have one squared number minus another squared number, it's going to factorize and look something like this. So the square root of whatever number this is, of whatever a is going to go in this bracket, and the square root of whatever b is goes here. The two same numbers will be in the second bracket. One has a minus in the middle and one has a plus in the middle. So looking at some examples, our first example, we have 12k squared plus 18. Now, it's not a difference of 2 squares. Reason being is that they're not square numbers. So what we're going to do is just take out a common factor. So the highest common factor between 12 and 18 is 6. So I'm going to take 6. So just going to write the highest common factor is 6. So I'm going to take 6 at the front of the bracket. Now 12 divided by 6 is 2, and I still have my k squared, plus 18 also divided by 6 is 3. And that is my factorized expression. Looking at b, I have 16a squared minus 25b to the power of 4. Now, looking at 16 and 25, we can recognize that these are square numbers. So what I'm going to do is I'm going to rewrite these numbers in terms of a whole squared number. So 16 can also be written as 4 squared. So I'm going to write 16a squared as 4a all squared. And we'd remember from our unit on indices that if we were to expand this bracket out, we would square the 4, which would get us 16, and square the a, which gets us the a squared. Doing the same to the 25, we keep the minus in the middle, 25b to the power of 4, I'm going to write as 5b squared to the power of 2. Reason I keep the b squared in here is because when I expand out these brackets, remembering that a power to another power, we multiply these together, so 2 times 2 would give me 4. And then to factorize this expression fully, I'm going to take this number, 4a minus 5b squared, and then I'm going to take the same two numbers but put a plus in the middle. So this number comes here, also goes there, and then the 5b is here and also there. Noticing that the only difference really is this plus and minus in between the brackets. Okay, now on to factorizing 4 terms. So if there are 4 terms to be factorized, look for a common factor first. So if there's one common factor that you can take out of all the numbers, do that first. Then you're going to group the terms in pairs. So the first 2 and the last 2, or you may need to rearrange. So looking at example A, I have x minus 4y plus mx minus 4my. So I'm going to group the first 2 and group the second 2 together. So with x minus 4y, I actually don't have any common factors, so I'm going to keep that as x minus 4y. Between mx and minus 4my, my common factor is m. They both have an m in common, so you're not just taking out letters, you are also factoring out, you're not just taking out numbers, you are also factoring out letters. So I'm going to factor out the m, and then my leftover is x minus 4y. Now, what you'll notice here is that I have 2 brackets looking exactly the same. So what you're effectively doing is repeating the process and taking out the common factor, which is that same bracket. So I'm going to factor out the x minus 4y. So that's one bracket. And then imagine there's a 1 out the front of this bracket. If there is no number out the front of the bracket, it's a 1. What you're going to do in a second bracket, where you're multiplying these two brackets together, so there's no operation in the middle here, the brackets are next to each other, I'm going to put 1 plus m. So the 1 at the front here and the m are going to go in this bracket. The x minus 4y goes in this bracket. You've taken out the common factor of x minus 4y, and then the leftovers go in our second bracket. Okay, now looking at B, I have x squared plus 3x minus y squared plus 3y. So first what I'm going to do here is I'm going to recognize that I have two squared numbers, another squared number minus a squared number. So I can actually do my difference of perfect squares with these two. So rearranging this so they're next to each other and it works out nicely. These are my difference of two squares. So referring back to how we factorize in the last example up here, where I have my squared numbers with a minus in the middle and the square numbers with a plus in the middle, I'm going to have x minus y and then x plus y plus, and then I'm going to have 3x plus 3y. Okay, now with these two, what we are going to do is then factorize this portion here. So I've got x minus y, that's just going to stay the same, and x plus y. Plus, now these both have a 3 in common, so I'm going to factor out the 3, and I'm going to have x plus y left in the bracket. Now again, what you'll notice is that my x plus y and x plus y I have in common, so I'm going to factor out the x plus y, and inside the second bracket, I'm going to have the x minus y plus 3. So that is coming from x minus y plus 3. And that's what's forming this bracket here. Okay, now sometimes it benefits us to actually group 3 and 1 instead of 2 and 2. So remembering back to our perfect squares that we looked at, this x squared plus 12x plus 36 makes a perfect square. So to factorize our perfect square, where we have previously looked at expanding perfect squares, but to factor back in the perfect square, our perfect square, we are going to square root the x squared and square root this number here. So I have x plus 6, square root of x squared is just x, and the square root of 36 is 6. And I'm going to square this bracket. Now this minus y squared just comes down here. I'm not doing anything quite with that yet. Now to put the y squared inside my already squared bracket, what I'm actually going to do is square root the y to put it into my bracket. Now what we have here is a difference of perfect squares. So I have this term squared minus this term squared, so that means it's a difference of two squares. So remembering that when I have a difference of two squares, I have a term plus my other term, and then I have my first term, which is x plus 6, minus my second term. So my first term of x plus 6 stays the same, and then my second term of y stays the same, but I've got a plus and a minus in between the two of them.